okay? Where F can also be written as m dot Vjet minus Va multiplied by Va divided by m dot F QCI. And again, you find here the fuel to air ratio. And we see like this that we have in fact introduced two parameters as in the gas turbine engines. One that is the thrust, and more specifically the specific thrust, and one that is related to the fuel, but this one is more complicated than in the gas turbine engines because it's related to the product of two different efficiencies, eta TH and eta P, leading to this eta global. You see that, in fact, we could also introduce a parameter like the SFC that we have here. So, how could you introduce a parameter like the SFC? You see that you could say, I take m dot F divided not by P, but by the thrust. This is by pure analogy that you would have that. And this is what is called the TSFC, in order to show you that we have a specific fuel consumption that is based on the thrust. And of course, this parameter is related to this one, because you see that the TSFC is here. Here you have 1 divided by the TSFC. So the TSFC is equal to VA eta global QCI. This is a constant. This is eta G, that is an efficiency. We like working with efficiencies. And this is a parameter with a strange unit. Here, the SFC, it was in kilo per kilowatt hour. Here, these are kilo per decanewton hour. Very strange unit, or kilonewton or newton hour. But mainly, what do we need to observe? Between eta global and the TSFC, it is not as with the gas turbine cycle. We have the presence of VA. And what do you need to do if you compare two engines? You can compare that based on their eta global, that is the product of eta TH and eta P, or you need to compare their TSFC, but if you compare their TSFC, you need to compare their TSFC at the same VA. So you cannot compare two engines based on their TSFC if you do not know that this TSFC is at the same VA. You need to compare TSFC at the same VA for the two engines that you are comparing. I think we are reaching the end of this lesson. I'm checking the time. So, what I would like to say, I will come back on that tomorrow. Look at this. So, we have this link between the TSFC and the eta global, but never forget that eta global is a product of two efficiencies. Put that in your mind. One is related to the quality of the cycle, the quality of the engine. The other one is related to the quality of the engine in the right aircraft. And what you need to have, this is both must be high. And so you must have a good engine in the good aircraft. Not only a good engine, in a bad aircraft, not only a bad engine in the good aircraft, you need to have the right engine in the right aircraft. And I will explain you tomorrow what I mean by that. And finally, so I insist on the fact that eta th for a turbojet is just influenced by Vjet square. There is no other way than increasing eta th thanks to Vjet. This is the only solution. I will come back on that tomorrow.